Okay, this study about thermodynamics. We learn how to predict spontaneity by calculating the free energy change delta G. Chemistry is the study of matter and its behavior. In kinetics, we have studied how fast chemical reaction can occur. In thermodynamics, we find how far they will go. Another fundamental goal of thermodynamics is the prediction of spontaneity. A spontaneous process is one that occurs without ongoing outside intervention. For example, drop a book in a gravitational field, the book spontaneously drops to the floor. A mechanical system tends towards lowest potential energy. What is the chemical potential that can predict the direction of chemical system? Well, the second law of thermodynamics said for spontaneous process, the entropy of the universe increases, or delta S universe larger than zero. Delta S universe can be written as delta S surrounding plus delta S system. At a constant temperature and pressure, delta S surrounding can be written as negative delta H system divided by T. Substitute this into the equation above, we get delta S universe equals negative delta H system divided by T plus delta S system. Multiply this equation both sides by negative T, we get negative T delta S universe equals delta H system because negative T cancel out, plus negative T times delta S system. So Gibbs defined negative T delta S universe as the free energy change delta G. Because for a spontaneous process, delta S universe positive number, T is a positive number, so therefore for a spontaneous process, delta G is a negative number. So we know, as a brief summary, spontaneous process have a negative delta G is less than 0, or delta G equals delta H minus T times delta S. For example, we can computing the Gibbs free energy change and predicting spontaneity from the delta H and delta S. Consider the reaction for the decomposition of carbon tetrachloride gas has delta H equals 95.7 kilojoules and delta S equals positive 142.2 joule per Kelvin. So first, calculating delta G at 25 degrees Celsius and determining whether the reaction is spontaneous. Use delta G equals delta H minus T delta S. Make sure delta H and delta S should be in the same unit and change the temperature in kelvins. So we substitute delta H. Given delta H is kilojoule, we multiply by 10 to the positive 3 become joules. 25 degrees Celsius become 298 kelvins. And substitute delta S. So we multiply these two numbers, and we adding these two together, we get a positive 53.3 times 10 to the positive 3 joules, a positive delta G, which means this reaction is not spontaneous at 25 degrees Celsius. Now we want to find out if any temperature, when the temperature is higher or lower than that temperature, the reaction will be spontaneous. To do that, we will think about the delta H sign and the delta S sign. So delta S is a positive number, and positive, negative. So this term here is negative, and as temperature getting higher, they're more negative. So delta G can become negative. So we are setting delta G become 0, and substitute delta H in joules and delta S in joule per Kelvin and T as a variable. Solve this equation, get T equals these two numbers divide, joule cancel out, Kelvin. So we have 673 Kelvin. Because we're predicting as temperature increases and this delta G will become more and more negative or less positive. So therefore, when temperature higher than this 673 kelvins, the reaction will be spontaneous. As a practice, let's study this reaction. Has delta H 137.5 kilojoule, delta S negative 120.5 joule per Kelvin. And we want to first calculate delta G at 25 degrees Celsius. and then decide how the delta G change as the temperature increases. To do that, we will use the same equation, delta G equals delta H minus T times delta S. For this practice, we are given delta H negative 137.5 kilojoule, change that into joules, so multiply by 10 to the positive 3 joules, minus temperature given 25, change 25 into kelvins, that becomes 298 kelvins, and the given delta S is negative 120.5 joule per Kelvin. So Kelvin comes out, and we will multiply the temperature with delta S. This negative become positive. We multiply 298 with 120.5, get 35,909 joules. Putting these two numbers together, we get negative 101.6 times 10 to the 3 joules. So at 25 degrees Celsius, delta G is less than 0. Therefore, the reaction is spontaneous. Now we were predicting how the delta G change as temperature increases. Because delta S for this given reaction is negative, so as we said here, we see here negative become positive. As temperature increases, this delta G will become more and more positive or less and less negative. We will set delta G equals 0. So therefore we get 0 equals negative 137.5 times 10 to the 3 joules equals T times negative 120.5 joule per Kelvin. And we solve this equation, we see T equals 139.5 times 10 to the 3 joules divided by 120.5 joule per Kelvin. Joule comes out, and we get 1141 Kelvin. So that means when T temperature higher than 1141 kelvins, our reaction will not be spontaneous. So as a summary, we learned how to use delta G to predicting the spontaneity of the chemical reaction, and we also studied how to predicting the change of delta G as temperature increases or decreases.